Hi folks, welcome back to the Integration Review video series. So we're in our 6th video here, and we're going to go ahead and get started with example 16. All right, so this will be our last example where we take a look at u substitution with an indefinite integral. All right, so by now, hopefully we feel pretty comfortable selecting our u. So usually the thing in parentheses or in the higher power is going to be our u. And so in this case, x squared will be our u. So u equals x squared. Now we're going to find our du, which is going to be the derivative of x squared is 2x dx. All right. Now, I look at the equation here, and I notice that I have 4x dx. And so what I'm going to do, instead of dividing this 2 away like I normally do, I'm just going to multiply both sides of this differential by 2. So on the left side, I'll get 2 du, and on the right-hand side, I'll get 4x dx, okay? Now, that works out really nicely because now, everywhere I see the 4x dx, I can replace that with 2u. I don't even have to take the 4 out of the equation. All right, so let's substitute. I've got the integral of sine u, and then 4x dx gets replaced by 2 du. Now I'm going to go ahead and bring that 2 out to the front, so 2, the integral of sine u du. And now when I integrate sine, I'm going to get negative cosine. So that'll be negative 2 cosine u plus c. And then in order to finish our problem, everywhere I see the u, I want to put back in my x squared. So this is going to become negative 2 cosine of x squared plus c. And that's what we get for our final answer for number 16. Okay? All right, so now we're going to move on to u substitution with definite integrals. Now this we'll see less frequently in Calc 2 than we did in Calc 1, but I just want to explain to you the way that I tend to set up my definite integrals, okay? So depending on the professor that you've had, you may have changed your bounds or you may have not changed your bounds. So I am a big fan of changing my bounds so that at the end, the only thing I need to do is plug back in the new numbers that I found, okay? So let me show you what I mean by that. I know that I have, in my integral, 1 plus 2x cubed, that's going to be my u, okay? That has a higher power than the rest of it, which is the x squared dx. So let's set u equal to 1 plus 2x cubed. And while we're here, let's go ahead and find our du. So du equals 1 goes to 0, 6x squared dx, okay? Now I notice that in my integrand, I only have x squared dx, so I'm going to go ahead and divide the 6 to the other side. Du over 6 equals x squared dx. Now, everywhere I see that x squared dx, I'm going to be able to replace it with du over 6. Okay, so that part's not different. But now let's take a look at the bounds, okay? Because when we substitute, the bounds that we have, if we change everything to u's, we need the bounds to also be u's. So let's see what we have. On the bottom bound, we have a 0. So what I'm going to do is I'm going to take 0 and I'm going to plug it into my equation for u. So u of 0 is going to be 1 plus 2 times 0 cubed, and that is equal to 1 plus 0, or 1. Okay, so my bottom bound is now going to be 1. My top bound is currently 1, but 1 is an x value. So what we're going to do is we're going to take 1 and we're going to plug it into the u equation. 1 plus 2 times 1 cubed is going to give me 1 plus 2, which is going to give me a new top bound of 3. Okay? All right. Now that we've got all of everything that we have, our integrand and our bounds with u's, now let's substitute. Okay? So when we substitute now, we're going to get the integral, not from 0 to 1, but from 1 to 3, of u to the 5th power times du over 6, okay? Everything I have in the integrand right now is in terms of u. Now, let's go ahead and factor out the 1/6. I have 1/6 on the outside, the integral from 1 to 3 of u to the 5th du. Now we're going to use our power rule to go ahead and integrate the u to the 5th. 1/6 times 1/6 u to the 6th, and I'm going to plug in 3, and I'm going to plug in 1. Okay? So let's bring this over here. I'm going to go ahead and take that 1/6 times 1/6 and make it 1/36. And that means that now I have 3 to the 6th minus 1 to the 6th. Okay? And now, what do we get? Well, we have 3 to the 6th minus 1 over 36. And it's okay to leave our answer like that. All right? So that's one of the things that you'll notice about Calc 2 is sometimes we'll need to simplify our answers, and sometimes this is about it. Like, we don't really need to simplify beyond this, but what we need to make sure we do is that we make sure we plug in the right numbers at the right place. All right? Okay. So that's example 17. Let's take a look at 18, which is going to be very similar, and I'm going to do the same thing where I change my bounds. All right, so our u in this case is going to be the thing in the exponent. And that's kind of a common theme with u substitution. Things with a higher power, things in parentheses, things in exponents, okay? So my u is going to be 4x squared plus 3. Let's go ahead and find our du. 8x dx. Now, as I scan through my equation, I notice that I only have x dx. And so what I need to do is divide both sides of my du expression by 8. Okay? Now, that's not different from our regular u sub, but what is different now is we also have to change our bounds. So my bottom bound is 0. So we're going to plug 0 into my u equation. And I get 4 times 0 squared plus 3, which gives me 3. Now let's take a look at the top bound of 1. I'm going to plug 1 into my u equation and get 4 times 1 squared plus 3, or 4 plus 3, and a top bound of 7. Okay? So once we've got our setup, so u's and du's, but also our bounds, now we can substitute everything in. So I'm going to get this equal to 1/8. Okay, so I'm going to take that 1/8 straight out from the du. The integral from 3 to 7 of e to the u du. Now, e to the u is one of our easiest integrals and easiest derivatives because the derivative and the integral of it is the same thing, or e to the u. So I've got 1/8 e to the u. I'm going to plug in 7, and I'm going to plug in 3. And so that'll give me a final answer of e to the 7th minus e to the 3rd over 8. And again, this is considered an exact answer, so we don't necessarily want to plug this into the calculator and get a decimal, because that's going to be way less exact, okay? All right, let's do one more here. So we've got our u. It's going to be the thing in the parentheses. So u equals pi x cubed over 2, okay? Now, it might be helpful for us to write this as pi over 2 times x cubed, just so that we can remember that pi over 2 is a constant. So now, when we find our du, we're going to have pi over 2 times 3x squared dx, okay? Now, let's see what we can match with our equation. Well, I have x squared dx, so I don't want pi over 2 3x squared. I got to get rid of the pi over 2 and the 3. So if I clean this up a little bit, I get du equals 3 pi over 2 x squared dx. And now I'm going to take the 3 pi over 2 and I'm going to divide it to the other side, which will give me 2 over 3 pi du equals x squared dx. So everywhere I see the x squared dx, I'm going to replace it with 2 over 3 pi du. All right, let's change our bounds. Bottom bound is 0. So u of 0 equals pi over 2 times 0 cubed, which is 0. So bottom bound stays the same. Top bound of 1. U of 1 equals pi over 2 times 1 cubed, or my new top bound is pi over 2. All right, let's go ahead and substitute everything in. So I now have a coefficient in the front of 2 over 3 pi, the integral from 0 to pi over 2 of cosine u du. All right? Now the integral of cosine is going to be sine, so I get 2 over 3 pi sine u, and I'm going to plug in pi over 2, and I'm going to plug in 0. This will give me 2 over 3 pi times sine pi over 2 minus sine 0. And when I substitute in, I'm going to end up with sine of pi over 2 is 1, minus sine of 0 is 0, and I'm going to end up with a final answer of 2 over 3 pi. Okay? All right, so we're going to stop here for this video, and we'll come on back to finish the last little bit of this section. All right, thanks so much. See you there.